Okay, so this is a quick overview of Chapter 9. This is the one we've only got to cover a little bit in class, but there's a couple of pieces I think are important that we at least want to touch upon as part of the class. Systems development, project management. As we talked about in this class, this is meant to be a survey class. So, one of the essential elements, for the stuff we've talked about of different types of systems and different kinds of functionality, like for example, with databases and things of that nature, one of the other major pieces that is part and parcel of information technology is this idea of systems development and project management. So this is what is, we're going to be using, these are the slides that are from the book. In addition, this slide deck I'm going through, I've actually taken some of this, I've hidden some of the slides, so it's actually shorter than the full set. And I'll actually be posting this up onto the Blackboard site so you can look at it. Okay. All right, so there's two pieces to this we're going to talk about. One is going to be this idea of developing enterprise applications, and then the other major part is this idea of project management, using project management to deliver successful projects and successful software. So this idea of a software development lifecycle, computer programming has been around for a while, and one of the challenges is developing software is hard, and getting it right the first time, or even the second time, or even the third time can be very challenging. All right. So what's happened is organizations have had, if anything, the growth of the use of information technology has actually put a premium on the ability to develop software. Everything you see running on a computer, it was coded by somebody or something, runs as software on a hardware platform. So, one of the challenges that's always been out there is this idea of trying to get things and be able to do it quickly, be able to do it correctly. So part of that has, one of the approaches that's been taken is this idea of a software development lifecycle, systems development lifecycle, which is really has developed over a number of years. So this is actually kind of a body of knowledge that's been developed over the past 40 to 50 years, and it still continues to be an evolving area. This is what we call, the term that gets used now a lot of times is software engineering. So this is really the what we call the SDLC, the software development lifecycle. There's really an expectation is there's 7 phases that are in this life cycle. All right. So the idea is you start off at the very top with a planning phase, basically trying to figure out what you want to, defining what is the problem, okay, or what do you need to have done. And analysis is taking that initial discussion, kind of building it out, providing details. Once that's been established, then a design can be developed, which is actually the high-level structure of what this application should look like and how it should all come together. Once the design is complete, then we have development. Development is the actual writing of code, right? Development and testing. A lot of times these two become back and forth, so it's not as straightforward as and we'll talk about this in a sec, that it's testing is extraordinarily important. Trying to get things right and verify that they are correct is an essential part of software development. Then implementation, which is basically turning things on. The implementation it can be a one-time event. It could be a rolling event. It can take many forms. And then finally, after the system has been developed and implemented, ongoing maintenance. Basically, the idea is the system is a living thing. Issues are discovered that were not caught in testing that need to be corrected. Improvements need to be made. New functionality needs to be added. So that becomes an ongoing. It's an ongoing part of the life cycle. Ultimately, coming back into, maybe another generation, another version of the software, as you just basically repeat the process again. So this is what we call software development lifecycle. The way you do this, though, there's different types of methodologies. So there's different, we have kind of our high level chart there, but there are a number of different ways you can go about this. So this is a list of some of the more well-known ones. All right, we'll kind of walk through them. So waterfall, something called agile, rapid application development, extreme programming, rational unified process, and Scrum. Basically, the thing to remember is these are all software development methodologies. They all are aimed and targeted to do the exact same thing as developing high quality software. The approach they take is different, though, as we'll see. So a waterfall is basically a sequence of tasks, of phases, in which the output of each phase becomes the input for the next. So the expectation is with this is that these phases are fixed time periods, and basically you go through each of the steps of the methodology: planning, analysis, design, development, testing, implementation, and maintenance. And each one follows the other. You complete one and then do the next, which then enables you to do the next and then to do the next. This is probably one of the longest established methodologies. Still, a lot of organizations use this, primarily because it's easy to kind of keep your get a grasp of kind of how things are developing. You can see, okay, where are you at in the course of a project? Okay, we are in the middle of our design phase, or we are planning and beginning our development phase next week. So it has a nice flow. It's easy for people to manage. It's easy for managers to kind of get an understanding of it. The challenge, though, especially with software, is that there's a lot of things you don't know, or things that you discover further downstream. So this is derived from engineering. So the idea, if you think about building a bridge, there's a pretty well-defined series of steps that have to be done for the design of a bridge, and you very much aware of that. Software, not quite as well defined, and a lot of times things will happen is that you can get a couple steps in to the waterfall methodology, get through the design, get into the development phase, and discover that you've got stuff missing. All right, so there's an expectation that this just follows in a straight line. The reality is it doesn't always follow quite as nicely as that. So there's been a lot of work done around, okay, even though waterfall has been predominant for a long period of time, there's been other methodologies which before you kind of come to the fore, like modern methodologies. So agile methodology is really the idea of doing things on an incremental basis. The idea is you don't plan everything up front. What you do is you develop kind of a core of functionality you're going to deliver that first, and then build upon that. So it's an incremental, it's a kind of an iterative incremental programming. So the idea is, the other thing about this is it also assumes a very close engagement with the people who are going to be using the software. So basically customer engagement through the entire thing. So it's actually more of a joint technology, IT and business initiative. So the business users and the developers are actually working side by side, creating the minimum, starting off with the minimum and then kind of evolving things over a period of time. The advantage here is that, if you don't know what you don't know up front, you can learn it and adapt and go through as you're proceeding through the implementation, the development, testing, and implementation. And these other ones are actually kind of of different variants of that. So this idea of rapid application development is the idea of once again, extensive user involvement, but very quickly establishing a prototype and then scaling a prototype up, developing a rapid implementation of initial implementation. So there's particular focus on doing things quickly, developing a small scale with the idea of being able to then build upon that small scale and build from there. So rapid application development actually has its own proponents. There's certain situations it's a very good fit. Other situations maybe not quite so much. Extreme programming is kind of a variant. Is kind of another play of agile. Basically, what it does is it takes the projects and divides it into little phases. So basically, instead of having one big implementation, what you end up doing is having the same project repeated again and again and again, in different with different phases. So iteration one, iteration two. This idea of being iterative in programming is actually one of the key focus areas of modern programming. The idea is you don't do it all in one shot. It's not a one-time only deal. It's an ongoing development that you incrementally identify, develop, test, deploy, and then kind of come back in. So this is kind of a variant of what we've seen with Agile. Uh, Another version of stuff, also a kind of a similar kind of process, rational unified process. You development into four gates: inception, elaboration, construction, transition. And within each of these gates, you can repeat, do things once again on an iteration. So the idea is that when you're in your inception phase, you can go through it multiple times, as many times as necessary to get things right before it moves into the next phase. Right. And then Scrum. So Scrum is also a modern technique. You see a lot of this with um, uh, software development organizations. So you'll see a lot of it with like companies like Microsoft and organizations like Comcast put a big emphasis. A lot of organizations have moved to both Agile and Scrum, or basically using Scrum as a means of developing an Agile platform. So you do is use small teams, develop small pieces of codes, and you put a time fence around it, what they call a sprint. And they call it 30 days, but it could be shorter than that. It could be whatever the team would design. So the idea is that very heavily engagement between both the development teams, the business users, kind of a formalized approach where each day will begin and end with a meeting, to kind of define what's going to happen over the day. You get to the end of the day and review what was completed and set up for the next day. So it's kind of a repeat, over again and again and again. So which one of these is the best one? Well, it depends on your circumstance. I mean, there's a lot of organizations that have been very successful with waterfall. It's not any one is best. It's really how it gets implemented. Each of these implementations, each of these methodologies can yield good results depending upon how it's implemented. So it's not a matter of Agile is always going to be better than waterfall. If you do a bad job of running waterfall, then you could probably see a waterfall. If excuse me, anything that if you do a bad job of implementing Agile, it could be that you would get better results using a waterfall approach. It's all within the implementation style. Okay, so project management. So project management is kind of an extension. So the methodology is how you write and develop the code. Project management is kind of a broader view of this of implementation. Basically, it's the idea of putting structure around the tasks to basically to make sure that you apply resources, engage stakeholders, and monitor and track for through a project or a set of activities through to an end. So there's a methodology. There's methodologies that have been established around project management. A lot of software work, a lot of software development work is implemented as projects. One of the things that's been discovered, and one of the things that's always been a big area of focus is basically, how do you develop successful software and using project management to do that? All right. And one of the things, there's been a lot of study around this, and there's certain things that have been seen, like why projects will fail. So things like, missing business requirements or skipping phases, or a big one, failure to manage project scope. Scope is basically the definition of how much work you're going to do. And what happens is there's a concept called scope creep and feature creep, where basically you say you're going to write a program A that's going to do certain functionality, And then at the end, that program actually does all sorts of additional functionality, which takes additional time, additional resources, adds a lot more complexity into it. So the idea is, one of the key challenges for project managers are to, keep both the features and the scope under control, and, focus on the delivery of the project. Right? So there's a lot of things. Project management has become a big topic area in the IT field. And you'll see a lot of that in, basically implementation, project implementations. So the idea is, one of the challenges and one of the key things from a software, using project management for software projects, is that the later you discover a problem, the more difficult it is, or the more expensive it is to fix it. So as you move through these different phases, if you discover stuff, in the implementation phase or in the testing phases, it's harder to fix than if you catch it within the planning and analysis phases. So the idea is that a big emphasis is put on, early on, trying to get things right, establishing the definitions, establishing the plans and analysis, making sure the analysis is correct and that the design matches the analysis. So this becomes an ongoing thing all throughout the execution and the implementation of the projects, of trying to make sure of targeting what's going to be delivered, what is going to be its capabilities, and then, be able to match and verify that those capabilities can be delivered. Give you an idea of kind of the importance of this stuff. The investment in, IT projects could be as much as $1 trillion. And what you'll see is the effectiveness, especially with IT, because programming is hard. You'll see, upwards of, 50, 60, we see 70% here can be lost of that investment. So trying to get it right the first time has always been a challenge. There's all sorts of the implications of a failed project, especially ones that have, very large cost associated with them. So the focus of project management has really been, not that it's a cure-all that will fix everything, but it really provides us the structure and the discipline to be able to, you know, coordinate the activities that are associated with a software project, because they're very complicated. Those are very complicated undertakings involving a lot of different people with a lot of different roles and a lot of different skills. So the fundamental, if you talk to a project manager, all right, as we talk around the different constraints of, obviously here we talk about, the implications of failure, and basically the track record for failure in IT projects are pretty significant. So the idea is from a project manager's perspective, there's really three things, well, four actually, that project managers need to be aware of. So there is what we call the triple constraint, which is, project manager needs to manage time resources, or time, manages resources, and manages scope. So those are the three things that a project manager needs to keep, basically under control, understanding where things are at from a timeline perspective, understanding what is happening in terms of resources, and then also what is happening in terms of work, in terms of the scope. And then on top of that, in terms of balancing these triple constraints, you also have the further challenge of managing the expectations of people. So, the role of a project manager becomes as much of it's a multi-dimensional position, because it requires a fair amount of understanding of on the business side of things, on the technical side of things, and then the ability to serve as a diplomat to manage the expectations through the execution of the projects, and the creation and ultimately implementation of what's being developed. So there's a couple terminologies here, just a couple terms that get thrown around with project management, definitions of a project, temporary activities, undertaking to create a unique product or service. The key word on this is a project is temporary. It's not a permanent. All right. It's a particular, a project is created and a project will end. Uh, Project management is the application of the knowledge, skills, tools, techniques, you know, to the different project activities. So there's something called a PMBOK or PMBOK, right, which stands for the project management um, body of knowledge, BOK, not BOC, BOK. So it's the project management body of knowledge, which is actually defined and maintained by the PMI, which is a organization that certifies project managers. So, and then the definition of a project manager: individual who is an expert in delivering project planning and management, develops the project plan, tracks the plan to ensure that it is completed on time and on budget, which are the primary the primary constraints. You want to make sure that is a project is within scope, it is on time, and is on budget. So this is just an example of what a project plan looks like, kind of an organization of the steps. Different tasks with the definition of start, stop, resources that are required with it. And this is so Microsoft Project becomes the primary tool. A lot of tools, a lot of organizations use to manage their projects, be able to detail and document stuff out. And having been involved with a lot of projects, these things can be maybe a couple thousand steps, spanning over longer periods of times with different resources and different work streams. So the complexities of these things can be very daunting, and it's really the job of the project manager to kind of keep everything in front of them and keep everything, be able to continue to move things forward and identify issues as they come up and be able to develop workarounds to continue to keep the project on track. So there's a one, I guess to wrap up here. So one of the things that's been happening over the past 10, 20 years is this concept of outsourcing. So outsourcing, has been it's not even a trend anymore. It's just simply a reality of how IT organizations are structured. So traditionally, or back about 30 years ago, organizations basically treated IT as their own, as an internal function, basically hired employees and people who worked for the company. What you saw though, there was a number of drivers around this. So some things were the really need to be able to bring in, the demand for resources, highly skilled resources, outstrip the ability for like local markets or even an organization to be able to develop and maintain everything they would need. In addition, the ability to tap into a global talent pool, the advent of the internet, the connectivity that provides was actually something that was really been leveraged extensively. So you're seeing a lot of outsourcing. So the definition of it's arrangement by which one organization should provide a service or services for another organization. And what will happen is a lot of times it's not limited to IT. All right, so IT is probably one of the better known examples. However, a lot of organizations have outsourced their HR function or have outsourced their procurement function. So if you we go back and look at our Porter model, we talk around these overhead or basically not on the functions that are not necessarily on the value chain. A lot of organizations have chosen to actually make them an outsourcing function as opposed to an internal function. So as we just talked about here, the drivers on this stuff, core competency, it's financial. There's a lot of times, I guess the initial idea is that, by outsourcing you save money, which may or may not be true. All right, so there's it's the way things are organized and managed. You may be able to save money, but then again, by the same token, depending upon the circumstance, you might not. So part of a outsourcing decision outsourcing is to weigh, any number of factors, and try to make sure the assumptions are the key variables are identified and the assumptions are validated as we go into this. All right. But once again, but beyond just simply the financial side, the rapid growth, the need for people, because programming and system support is a fairly labor intensive activity. And then leveraging the internet and globalization as part of that. So we talk about it. The idea is inexpensive, good work. The problem, though, from the time this chart was originally made, is things change. All right. So what's happened is in countries like India and China and the Philippines, what happens is that their actual um, resources, actually, the price of resources go up there. People end up, technical people end up uh, making more money. So one of the interesting things that's been happening with offshoring is it seems to move. Sometimes the sweet spot moves. So you saw a lot of stuff in India and in China, but then you saw kind of a rise in with countries in Eastern Europe and also in Africa. So this is not this is not necessarily a static thing. So things do move around a bit. Benefits, if depending upon how well it's done, if it's done well, you can see an improvement in the quality and efficiency of processes. You can take out costs. Actually, one of the big things is operating costs for headcount, for large capital investments. The idea of, if it's not core, if it's not on your value chain, then, you really should think about it not of just treating it as an outside resource. The ability, if you can align with a good service provider, that they can provide economies of scale and best practices and expertise that an organization might not be able to get to. And then also the idea of being flexible. So the idea of flexibility, these organizations, you add resources as you need them. You can shift resources as you don't need them. So the idea is, if it's done well, you can achieve a lot of flexibility and be able to react to different circumstances. So this is so outsourcing is a very real thing in the IT world or in the technology world. However, you've also seen organizations have decided to, the organizations will decide to outsource. They will outsource, and then they'll decide to bring things back. So a lot of what we've seen is this sort of I think the best way to put it would be sort of a validation, kind of rebalancing of exactly what you should be doing, what things you want to have in-house and maintain within the organization, and what things could be more effectively outsourced. Some outsourcing, the challenges around it. We talked about the fact that it is a contractual arrangement, making sure that all of the different you know variability scenarios, things of that nature. Like, one of the things that always becomes an interesting thing, especially with offshore, is the political stability of a country, of whether or not, if you outsource to another country and there's some sort of political disruption, would that have a negative impact on your operation? So these are all the different kinds of things that need to be taken into advantage. Also, the question of, you want to make sure you don't outsource anything that you hold as a competitive advantage. All right, if that would be, some organizations will just arbitrarily move everything out. You really need to take a look at it and understand what the value proposition of everything that's out there, and validate that you're not taking anything out of the organization that really you want to keep in house. And finally, loss of confidentiality. I mean, what will happen is your stuff is going outside of your organization. It's outside of your physical outside of your physical premise. So being able to manage that, the security of it, the recoverability of it. These are all key things that need to be taken into consideration before you let things go out the door. And that is the end for Chapter 9.